According to the National Electrical Code, specifically Section 210.8b2, neutral conductors are permitted to be shared by more than one circuit. Additionally, Section 406.4 states the neutral conductor is permitted to be shared in branch circuits supplying receptacles for loads where grounding type receptacles are not required. Most GFCI receptacle manufacturers state in their datasheets that their receptacles can share a common neutral. For instance, the Leviton 50 amps GFCI receptacle datasheet specifically states the neutral conductor can be shared with other circuits. Sharing a neutral can sometimes increase the likelihood of nuisance tripping, especially on circuits with high harmonic loads such as electronic devices. Utilizing a common neutral can significantly reduce conduit fail, which is especially beneficial in areas where space is limited. When installing GFCI receptacles in areas, it is acceptable to share a common neutral provided certain conditions are met. Firstly, the circuits must be dedicated to non-refrigerated loads only. Secondly, the load should not have high harmonic content. Thirdly, conduit fill should be within allowable limits. If these conditions cannot be fully satisfied, it is recommended to provide separate neutrals for each circuit. This approach can minimize the potential risk of nuisance tripping and ensure a more stable electrical system. To ensure proper electrical installation and adherence to safety standards, always consult the most recent edition of the National Electrical Code and follow manufacturer specifications for all electrical devices. The NEC provides comprehensive guidelines for electrical wiring and equipment installation, promoting safety and preventing electrical hazards. Understanding the code requirements and manufacturer recommendations is crucial for qualified electricians and electrical professionals. When dealing with GFCI receptacles and shared neutrals, it is essential to consider the specific application and load characteristics to determine the most appropriate wiring configuration. Carefully evaluate the potential for harmonic currents and the impact on neutral conductor loading. If harmonic currents are present, it may be necessary to provide separate neutrals or employ other mitigation techniques to prevent overheating and ensure proper circuit operation. Always use appropriately sized conductors for the intended load and adhere to the NEC ampacity requirements. Proper grounding is also critical for GFCI receptacles to function correctly and provide effective protection against electrical shock. Ensure that the grounding system is properly installed and maintained to minimize the risk of electrical hazards. Regularly inspect electrical systems to identify any potential problems and address them promptly. This includes checking for loose connections, damaged wiring, and malfunctioning devices. Proactive maintenance can prevent electrical failures and ensure the continued safe operation of electrical equipment. When making any electrical modifications or additions, always obtain the necessary permits and inspections to ensure compliance with local codes and regulations. Working with qualified electricians who are knowledgeable about the NEC and local requirements is essential for ensuring safe and reliable electrical installations. Failure to comply with electrical codes and regulations can result in fines, penalties, and potential safety hazards. By following best practices and adhering to industry standards, you can create a safe and efficient electrical system that meets the needs of your facility. Electrical safety is paramount, and it is crucial to prioritize safety in all aspects of electrical work. Always energize circuits before working on them and use appropriate personal protective equipment, such as gloves and eye protection. Never work on live electrical circuits unless absolutely necessary, and then only with specialized training and equipment. Electricity can be dangerous, and it is essential to respect its power and take precautions to prevent accidents. Continuously update your knowledge of electrical codes and technologies to stay abreast of the latest developments and best practices. The electrical industry is constantly evolving, and it is important to stay informed to provide the best possible service. Consider attending industry conferences, workshops, and training courses to enhance your skills and knowledge. By investing in your professional development, you can ensure that you are providing the highest quality electrical services and maintaining a safe working environment. Electrical engineering is a vast and complex field, and it requires a commitment to continuous learning and improvement. By staying informed and following best practices, you can excel in your career and contribute to the advancement of the electrical industry. Always refer to the latest edition of the National Electrical Code for the most up-to-date requirements and guidelines. The NEC is revised every 3 years, and it is essential to use the current edition to ensure compliance. The NEC is a comprehensive document that covers a wide range of electrical topics, and it is an invaluable resource for electrical professionals. In addition to the NEC, consult manufacturers' specifications and technical documentation for specific electrical devices and equipment. Manufacturers provide detailed information about their products, including installation instructions, performance data, and safety precautions. Following the manufacturer's recommendations is crucial for ensuring proper operation and preventing equipment failures. When troubleshooting electrical problems, use appropriate testing equipment and follow safe work practices. Electrical troubleshooting can be dangerous, and it is essential to take precautions to prevent electrical shock and other hazards. Use a multimeter to measure voltage, current, and resistance, and follow established procedures for identifying and resolving electrical problems. Document all electrical work, including wiring diagrams, test results, and any modifications or repairs that are made. Accurate documentation is essential for maintaining a safe and reliable electrical system. It also provides a valuable record for future reference and troubleshooting. When working with electrical panels and distribution equipment, always follow lockout/tagout procedures to prevent accidental energization. Lockout/tagout procedures involve disconnecting the power supply and applying locks and tags to prevent the equipment from being turned on while work is in progress. This is a critical safety measure that can prevent serious injuries and fatalities. Regularly inspect electrical panels and distribution equipment for signs of damage or deterioration. Look for loose connections, corroded components, and any other indications of potential problems. Address any issues promptly to prevent electrical failures and ensure the continued safe operation of the electrical system. When installing electrical conduit, follow the NEC fill requirements to prevent overheating and damage to the conductors. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit based on the conductor size and type. Exceeding the conduit fill limits can cause overheating and potentially lead to electrical fires. Use appropriate fittings and connectors for electrical conduit to ensure a secure and watertight connection. Proper conduit installation is essential for protecting the conductors from damage and ensuring a reliable electrical system. When working with underground electrical wiring, use appropriate burial depths and follow the NEC requirements for protecting the conductors from physical damage. Underground wiring must be buried deep enough to prevent damage from digging or other activities, and it must be protected from moisture and corrosion. Use direct burial rated cable or conduit to protect the conductors from the elements. Regularly inspect underground electrical wiring for signs of damage or deterioration. Look for any evidence of digging or other activities that could have damaged the wiring. Address any issues promptly to prevent electrical failures and ensure the continued safe operation of the electrical system. When installing electrical equipment in hazardous locations, follow the NEC requirements for explosion-proof or intrinsically safe equipment. Hazardous locations are areas where flammable gases, vapors, or dusts are present, and special precautions must be taken to prevent explosions. Use equipment that is specifically designed and approved for use in hazardous locations. Ensure that all electrical equipment is properly grounded to prevent electrical shock hazards. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Use appropriate grounding conductors and connectors, and ensure that the grounding system is properly installed and maintained. Regularly test the grounding system to ensure that it is functioning properly. Use a ground resistance meter to measure the resistance of the grounding system and compare the results to the NEC requirements. Address any issues promptly to maintain a safe and reliable electrical system. When installing surge protection devices, follow the manufacturer's recommendations and the NEC requirements. Surge protection devices protect electrical equipment from voltage surges caused by lightning or other events. Install surge protection devices at the service entrance and at sensitive equipment to minimize the risk of damage. Regularly inspect surge protection devices to ensure that they are functioning properly. Look for any signs of damage or deterioration and replace the devices as needed. When working with high-voltage electrical equipment, follow strict safety procedures and use appropriate personal protective equipment. High-voltage electrical equipment can be extremely dangerous, and it is essential to take precautions to prevent electrical shock and other hazards. Only qualified and trained personnel should work on high-voltage equipment. Use appropriate insulating gloves, sleeves, and other personal protective equipment. Always de-energize the equipment before working on it, and follow lockout/tagout procedures to prevent accidental energization. Regularly inspect high-voltage electrical equipment for signs of damage or deterioration. Look for loose connections, cracked insulators, and any other indications of potential problems. Address any issues promptly to prevent electrical failures and ensure the continued safe operation of the electrical system. When working with renewable energy systems, such as solar, photovoltaic, or wind power systems, follow the NEC requirements for these systems. Renewable energy systems have unique electrical characteristics, and it is essential to follow the NEC requirements to ensure safe and reliable operation. Use appropriate disconnects and overcurrent protection devices, and ensure that the system is properly grounded. Regularly inspect renewable energy systems for signs of damage or deterioration. Look for loose connections, damaged wiring, and any other indications of potential problems. Address any issues promptly to prevent electrical failures and ensure the continued safe operation of the system. Stay up to date on the latest technologies and best practices in the electrical industry. The electrical industry is constantly evolving, and it is important to stay informed to provide the best possible service. Read industry publications, attend conferences and workshops, and participate in online forums to learn about new technologies and best practices. By continuously learning and improving, you can excel in your career and contribute to the advancement of the electrical industry. Always prioritize safety in all aspects of electrical work. Electrical safety is paramount, and it is essential to take precautions to prevent electrical shock and other hazards. Follow safe work practices, use appropriate personal protective equipment, and never work on live electrical circuits unless absolutely necessary. By making safety a priority, you can protect yourself and others from harm.